Hey there, how you doing? Welcome back. Here we go again. We're going to learn how to correctly translate expressions. The key thing that we're going to focus on is like when you have two unknowns, but you need to have them both defined with one variable. So we're going to correctly translate expressions for two unknown quantities using only one variable. Okay, so there's two things we don't know, but we only want to use one variable. So here we go. Let's see. I always forget this. Why do I always forget this? I don't know. I guess so I can chit-chat with you while I'm doing this. All right. Here we go. Here we go. All right. So as we've been seeing, as we practice translations, some of them are really straightforward. It's just a sum or a product. For example, so you football boys, Frank, Dentrell, and anybody else in there that I've missed, if a football gains 6 yards on the first down and 7 yards on the second down, write an expression that describes the total yards gained for both downs. Okay? So that's a straightforward expression, right? We're going to add the two. Total would be add the two together. So this would be like, hold on, let me get my stick here. This would be like sum, right? Sum the yards up. Well, what are the things that we have to sum up? X was the first one and 7 on the second one. So all you do is write an expression x plus 7, okay? With multiplication, it might look something like this. Tom has R quarters. That's the number of quarters he has. We don't know exactly what it is. We don't know exactly how many he has, but we're saying that it's R. Write an expression that indicates the value of the quarters in cents. Well, what is the value of 1 quarter? Well, that's 0.25, right? 0.25, okay? So all we would take is 0.25 times R. Okay, that would be our expression. We would just straight multiply them together. If you don't like those parentheses, which I don't blame you, that's okay, it would be 0.25 or 0.25 times R. Okay? So try this one. Monica is T years old. We don't know exactly how old she is. We just know that she's T. Write an expression that represents her age in 12 years. 12 years from now means we want to add 12 years, right? Okay, so this would just be T plus 12. Okay, why don't you hit pause, try D, and come back and see if you got it right. All right, Frank, did you do it? Okay, welcome back, Frank. Here we go. Monica is 2 years old. Write an expression that represents her age 2 years ago. 2 years ago. So that would be, we would have to subtract, right? Subtract. How old were you 2 years ago? You would subtract 2 years from your age. So this would be T minus 2. Don't be fooled into thinking it's 2 minus T because you aren't 2 years old. You're T years old and you're subtracting off 2. All right. Other times it's not so straightforward. We don't know the two things that are being added or multiplied. Instead, what we know are one of the things, and then the sum or the product of those things. And we have to find the other thing. Okay? Lots of things. I know. I think of Dr. Seuss every time I use the word thing. Okay, so let's look at an example. All right? I have a baseball player who got 65 hits in one season. If he got 8 hits in one game, all right, write an expression that describes the number of hits he got in all the other games. So this right here is the sum of all the hits. All right? This is what he got in just one game. H is hits in one game. Okay? So, the expression that we need is if the number of hits he got in one game plus all the others, hits plus all others equals 65, then what does all others have to equal? Well, all others has to equal 65 minus h. It's like you're solving for all others, right? 65 minus h. Because if I would subtract h from both sides, all right, that's how I would get it, right? Okay. All right, so some kind of shortcut techniques to help you when you need to express two unknown variables, but you only want to use one letter and you're given the sum of the two numbers. First, name one variable. It could be an H, it could be an X, it could be Y, it could be Z. You can choose any letter. Then the other one is going to be whatever the sum is, okay? You're going to be given a sum minus the variable, all right? So let's see how this plays out. If two numbers have a sum of 23, two numbers have a sum of 23. If one number is K, find an expression for the other number. So step one says name a variable K. Okay, so the first variable is K. The other variable has to be the sum minus K. All right? What's my sum? 23 minus K. So here's the expression for the other number, 23 minus K. All right? Try this next one and see how you do. Okay, two numbers have a sum of 11. If one number is Q, find an expression for the other. Okay, so I'm going to name, they've told me, name of one variable is Q. My other variable has to be what? Sum minus Q. And what's my sum? 11. Just as easy as that. This is the answer that you're looking for. 11 minus Q. Sorry, I'm about to sneeze. All right. Very similar when you're going to express two unknown variables using only a single letter, and you're given the product. Okay? Name one of the variables, pick a letter. Then the other one is going to be the quotient or the division, the product divided by the first variable. So now we're going to use division, all right? If two numbers have a product of 24, if one number is called K, so I've named it K, name equals K, all right? Find an expression for the other number. Well, the other number has to be the product divided by K. What is my product? That's 24. So it has to be 24 divided by K, just like that. You try the second one and see if you can come up with the right answer. All right, welcome back. Here we go. Two numbers have a product of 9. If one number is R, find an expression for the other. Well, one number is R, that's my one variable. My other variable has to be 9 divided by R. It's the product divided by the variable that we've named. All right, a bank teller has D dollars all in $5 bills. So he has no other bills except $5 bills. Write an expression that represents the number of $5 bills he has. All right? So my product is D. Do you see it? Because that's the amount of money that he has, is D dollars. It's okay that we don't know it. All right? So I know my product, and I know my one variable. The amount per dollar is $5, right? So my expression that I'm looking for is D dollars divided by $5. That's going to be the number of bills. Okay? Another way to think of it is if you did it long ways, it would be $5 times the number of bills, right? Has to equal what? D. Okay? So, how do I get the number of bills all by itself? I have to divide by 5. So the number of bills has to equal D divided by 5. Same thing. All right. Okay, another type of translation, and this is our last slide, and this is very, very fast, okay? A plane ticket costs $A for an adult and C dollars for a child, okay? So A is dollars and C is dollars. Write an expression that describes the cost for 3 adult tickets and 2 children tickets, okay? So what A equals cost of adult ticket. C is the cost of child ticket. If I want to know how much 3 adult tickets would cost, what would I do? That's just a straight multiplication. 3 times A. Okay? If I wanted to know just the cost of 2 children tickets, that would be 2 times the cost of 1, 2 times C. If I want to know both of them, then I add them together. Just like that. That would be the expression for 3 adult and 2 children tickets. Fast and furious, woohoo! All right, I'll see you tomorrow. Have your working fingers on. We're going to do 48 through 70 even, and then we have some review. This is kind of a mixed review. All right, so I'll see you tomorrow. Enjoy your evening. Thanks for listening. Bye.